Alright, so the real problem here, okay, with these arguments, right, is not just that they don't make sense, right? It's that there is historical precedent for exactly this kind of claim limiting, holding back mathematics, right? When all you have is the positive whole numbers, the positive natural numbers, right? Which there is a documented period of history where that is what mathematics was. Zero was not considered to be a value that you could work with at all. Okay. Right? All you had was the integers. So the positive whole numbers. Right? You don't have negatives, you don't have zero. So division was they didn't think of it this way, but it wasn't a problem because 7 divided by 4, well, it's just not, you get 1. And then if it's something that you can divide up into other pieces, then you just keep getting 1 of some fraction of it, right? So you take the whole thing and you chop it up. This is how you get Egyptian fractions. Okay? So you always end up with a whole number of things. Okay? So this was solved. Throw in 0. And at the same time, like, you can't have negatives or something, right? So 7 minus 18 doesn't even make sense. Okay? So why are we worried about what is 7/4? Why are we worried about that? Right? Clearly there's things you can't do, so we just don't worry about it. And doing only the things that we understand where it makes sense, that makes us gods, and we can do whatever we want. And we just say that that's the limit of mathematics, and this is perfect, and we don't look at the holes. We don't worry about the problems. Okay? That's exactly what's happening here. Or, how do you take the square root of a negative number? Well, you just don't. You just don't. Well past the time where the imaginaries were defined and partially understood, like significantly understood. Into Euler's time, there were people claiming that it doesn't make sense. And still regularly students today claim that it doesn't make sense. Because how do you have imaginary numbers? They're not even real. What does this mean? Because they take the names too seriously, and the reason that they're even named that way is because of people who rejected that they were even possible well after it was demonstrated how they work. Okay? So what I'm saying here is this is exactly the same thing. What you're doing is you're saying, oh, we have this perfect system. And it's just silly to insist that the reals should be, we should consider closure of the reals under division to include 0. That's a weird thing for you to insist. Why would you insist that 0 be partake in that? Because blah blah blah, and then it's this just philosophical bullshit that comes down to, I think it's gonna come down to how you define everything. And then it's the same shit, right? Can't we say that the natural numbers, so let's see, the natural numbers, not including 0, the natural numbers are closed under subtraction. Can't we say that? If it just comes down to how we define everything, we could absolutely say that, using exactly the same logic that this guy here is using. Exactly the same logic. You could say that the natural numbers, excluding 0, are closed under subtraction and division. Exactly the same arguments work for that. You just change some of the details. You just change the details in here. We're like, oh, instead of talking about, we call those structures rings. Instead of that, you just make up some other bullshit that explains away why you don't have to consider all of the elements, when your definition for closure is that all of the elements of the set, every single one of them, needs to be able to go on either side of the operation in order to get the fucking thing to work, in order to get a closure. Oh no. Oh no. We can ignore this one. We can ignore this category of solutions over here. Because honestly, zero divided by anything is zero. So this actually introduces a huge category of solutions. It's not just one. It's not really just when zero is the divisor. It's also when zero is the numerator, is the denominator and numerator. And any other element of the set as numerator opposite of zero, as numerator denominator opposite of zero. It's like, that's a huge set. That's an infinite set that doesn't work. you get an infinite set of problems that fail. That's exactly the same as if we were trying to do the same shit and say that the natural numbers are closed under subtraction. Yeah, you get an infinite set. Right? Amazing. It's the same logic, but they don't see it. They're like, oh no, this one's justified because it's us. We're different. That's what I mean when I'm saying this is narcissistic. It's grandiose narcissism playing out in a kind of a weird way, but it is absolutely some sort of narcissism, and I'm just gonna say it's grandiose because the motive for it is to make them look like they know everything, to make them look like, oh, we got this, even though they're blatantly contradicting themselves. They're fuck, I don't understand the logic of this, right? You have this definition of closure that's handed to you, and you're like, yes, we're obeying this definition of closure by defining our way out of it, where we don't have to actually obey the definition of closure. What the fuck? What the fuck? Like, if you just want to reject the definition of closure and go with something else that actually works, like where the definitions of the things that you're now using actually works, okay. But don't sit here and say, oh, we can define our way out of actually following the definition of closure. No, fuck you. What? That's just stupid.